Hi, this is Andre. This is going to be a video about setting up sequencers in the method that I like them, where you have basically 8 running one after another. You have an option for how many of them are playing, so the length, and then you have an option for direction and clock quantizing. And I already did a video that shows exactly this as part of my series I was doing on setting up a sequence glitch sampler in the grid. But I was working on the next parts of the series, so setting up the stutter sequencer and the slicer, and I realized there was a couple of problems in the patch that I had done before, and I thought, it's rather than making a video trying to fix all the problems from the last one, it would be easier to just build it fresh from the ground up. So yeah, if you did follow that video, those videos, sorry for the problems in it. It looked visually fine, but they were being combined in a weird way. And the reason that was because basically when I did those videos, I was I had a few different versions of the patch. It was like from a year ago, and I just was doing the wrong one. So I decided to just scrap the whole thing and rebuild it from the ground up so I could just make sure everything was working. And so, yeah, I have this. So now I'm going to do this video showing this part, so how to set up the sequencers, and then I'll do just a separate video showing the stutter sequencer and the slicing sequencer. So anyway, basically what we're building right now is going to be just these rows of sequencers. And if you wonder why I like it this way, for one, I like the visual of being able to just see where I'm at in a sequence. I also like that to be able to change the amount of steps at a certain part. So like, for example, over here, if I want this to be a triplet, I could put it at 6 steps or 3. And then this gives me the option of changing the length of the sequencer, and yeah, few different things. I mean, if we had the option of color coding steps, I probably wouldn't go through all this work. And it is a bit of a setup. You can see that it's all this stuff, but it doesn't take that long to set up. It's about half an hour to an hour to set up the whole thing. And then once you have it, you can just save all this and reuse it for any patch that you have sequencers in. And hopefully, if one day we get containers within the grid, all this could just be contained within a little module that you don't even need to see, that would just have the outputs that you need. So anyway, let me show you what this sequencer looks like. So you have 8 sequencers, and here I have a little oscilloscope, and you can see these values are going up, so you can kind of see that it's all working. So here, if I hold a note, you'll see each one of these sequencers playing periodically, and you see the values up here. Okay, and then we have a length knob, so if it's all the way here, you hear one sequencer. So that's just all the way down because the values are low. If the length knob's over here, you have 2. If it's over here, you have 4. And then all the way up, you have the 8. And then, so you have a direction control over here. So over here is reverse. You can see that for each length, it works. If we go all the way, it'll start from there. And then we have over here is pendulum. So if we have all 8 sequencers, you'll see it'll play through forward over here, and then it'll do reverse when it gets to the end. And again, that works for any length. So if we're on the 4, it'll be like this. Or that's the 2. It'll be like that. And if it's on the 4, it'll be like that. And then lastly, we have random. And then we also can half or double the time. So here's really fast, here's really slow. Okay, so now that you know what this is, I'll go through and rebuild it. And I'm probably going to end up deleting the other video that I had because, like I said, it had a couple problems. It wouldn't be too hard to fix it, but I think this way is a little bit cleaner. Like, one of the problems with the grid is sometimes the first note misses, and I've noticed that having merge and split modules in there sometimes messes it up, and I'm not sure why. So anyway, the first version I had like 4 of these logic sequencers, and then I had basically a scaler doubling the phase, and a logic setup that said that once it hit 50%, it would switch over to the next 4, and I had them going into merge modules. Anyway, it was a whole complicated setup. I think this way probably works better. The reason I did it on the other one was because on that one I didn't need all these, but I think it's better to just add all these logics over here. And I know it looks a little complicated, but I'm going to try to go through very slowly and explain for every part why I'm doing what I'm doing, so you can apply these same ideas to other patches. And I think this video will be better than the other one because, like I said, that patch was like a year old. My head wasn't very fresh into what was going on. I just kind of took a screenshot of the old patch and redid it. So I think this one will make more sense. So yeah, so let's just start by opening up a new polygrid. I'm just going to delete these for now. And then, my screen just disappeared. All right, it's back. So now let's take a transport, and I didn't do this on the last one because it was a series of 4 and 4 sequencers, but for this one, I'm going to change the timing to 32/16. Okay, and then I'm going to run that into a reset, and then I'm going to run this into a selector, put it down here, and put a gate. And there's a bunch of different ways you can have your main time being run. You can have it from the phase. You can have it all sorts of ways. The reason I like it like this is that every time I let go of the key, the selector goes over here, so you have no signal in. And I like that just so it doesn't get hung up on the last value, because like I said, sometimes these grid patches can be a little weird where like when you first hit a note, it gets caught up on the last value and it doesn't snap back to 0. So I think that this helps with that problem. It might just be in my head that it's helping with it, but I think it is. So if you look over here, you can see the values that are coming out. You see right when I let go, it snaps back down to 0. All right, so we can just say that this is our main global time. And usually I put a clock divider and multiplier for the global. I'm not even going to bother doing that right now because I just want to make this video not take super long. And I think I'm going to add the direction afterward. Let's just start for now with a basic clock divider and multiplier for the timing for this section. And if you didn't see my original video where I was showing my glitch sequencers, so usually I like to have the various sequencer lanes running independently so they can have their own clock dividers and multipliers, they can have their own direction and all of that. So I'm going to show you how to do that on a further video. Right now I just want to build one of these sequencers so people can have it, and I'm probably just going to upload this patch to wherever it is that the patches are shared. Okay, so yeah, I can't remember the name of the site. So if we get the value over here, let's just call this time, or timing, and we'll get 2 scalars from the phase. And then just have one of them be 2/1, one 1/2. The center one will go right through. This will come from here. So this select we can just call global time. All right, and now, so like I said, I'm going to skip over the whole direction part. I'm going to add that, I think, at the end. And I'm going to kind of try to do this one step at a time. So some of these things I'm going to do, I'm going to have to unwire and change them, because first I want to set up basically the 8-part sequencer, and then I'll add the length, and then I'll add the direction. And if you've seen some of my older videos from like a year ago, the reason I'm doing these 8-part sequencers with, or any of these kind of sequencers where it plays one sequencer into the other, you could do these things with split merge modules instead, but when I tried to do that before, the timing was screwed up and it would just be glitchy and run all over the place. So in the end, this is kind of the method I came up with to have it work accurately and have the timing clean. So what we're going to do for these is we're going to basically divide the phase. And if you haven't used timing or sequencers in the grid, I'm not talking about the phase of a waveform, but basically they think of timing as phase. So like, a bar of time, imagine being like a ramp starting at 0 and ending at 1. So the phase is always 0 to 1. And so basically, that's what's coming out of here. If you look where my mouse is over here, you see that's starting at 0, it goes to 1. So that's basically our phase timing. So what we're going to start with is a series of logic modules. We're going to get a bunch of greater thans and a bunch of less than or equal tos. So, and then a bunch of so for this part of it, you can do either a constant module or a shift. And I'm doing a shift because you can get smaller values with the shift. You can do, I think that was also why on the other one I had 4 and 4 because I was using constant modules. But if you're dividing it up by 8, I'll just use the shift module. And so we're going to get one of these. And then for each one, we'll also get an and then we'll get a select. Okay, and we're going to copy these 8 times. Oops. Or not copy them 8 times, copy them 7 times. So we have 8 of them. Okay, and then first thing we're going to do is we're going to run our time. So our time now is coming out of here into the top input of each one of these logics over here. So let's just get those. Probably would have made more sense to copy that in first and then duplicate these, but anyway, it won't take too long. And then basically, so we need to divide 1 by 8. So we're gonna get 12.5. So the first one will just be 0. The second one will be 12.5. The third one will be 25. So this is 25%. Yeah, I mean each of these are percents. And then the next one will be 37.5. The next one will be 50. The next one will be 62.5. The next one will be 75. The next one will be 87.5. And then we're going to need one more that'll just be 1. Or actually, let's just use a constant for the last one. I don't know why the shift wasn't working well for me when I did that. So let's just grab a constant for the last one. And so basically, the whole idea is that what we're doing is that we're saying that if the phase over here is greater than this value and less or equal to this value, then it'll open up this select module, which will allow the phase to run through it. And first thing we're going to do too, because we're going to have 8 sequencers, we have to multiply. We have to have the phase be a lot faster so that each sequencer starts at the bottom phase and ends at the top phase. So we'll get a scalar from the phase, run it over here, and we're going to make it 8/1. If you remember the other video I did showing these sequencers, it was 4/1 because, again, I had 2 blocks of 4 sequencers. But for this one, we're just doing 1 of 8. And either method works, but this is just what I'm doing here. So these will run into the bottom inputs of all of these. Okay, and then the way we're going to wire these up is we're basically going to say that, so for the first one, it'll be if it's more than 0, and then this one will be the next one down. So it'll connect to this one. And then we'll say, here, let's just do that for each one. So this one comes from here, this one comes from the one below. This one comes from here, this one comes from the one below. And yeah, hopefully you can see all this, but I think you should get the idea of what's going on. All right, and now what we're going to do is we're just going to run each of these into the AND for each row. And I mean, this is kind of replicating what the what the split module does, you know, if you were just to modulate through it. But unfortunately for me, like I've demonstrated on another video, just the timing doesn't work right with the sequencers. It gets jumpy when I try to do it that way. Okay, so now each one of these ands will just be the control input for one of these selects. Okay, and so now let's grab some sequencers, or some, what do you call them? Let's get these steps. Let's turn off the phase input. Let's set it to 4. And maybe so we can see what we're doing easily, let's just draw in values that are kind of going up for each one, just so we can use an oscilloscope to make sure that the values that we're going to be running in are correct. So I'm just going to try to kind of get each one of these sort of going a little higher than the last one. I mean, this doesn't need to be exact. It's just simply for the visual so that you can run it into an oscilloscope, like I was saying, and make sure that all the values are doing what they're supposed to be doing. Is that 8? Yeah, it should be all 8 of them. Here, let's bring this one up all the way. All right. Might be a subtle difference, but you'll be able to see. So basically, right now we can just run each one of these into these. And then let's hold a key. And you can see that that visually is doing what it should be doing. Okay. And now, so the way that we are going to combine these, and yeah, it's a little bit more complicated when you're doing these 8. You need more of them than when you do. So remember, the other one, again, I had 4 that would switch to the first half of the 4 and the second half of 4, and I would just have a logic that would switch them. But for this one with 8, we need a few extra modules. And again, you know, you would think that you would do this with a merge module, but it just doesn't work for me for some reason. So I'm just using these. So the first one of these, so we're going to use a bunch of selects. Let's call this one 1, 2. We'll make one, we'll put one over here. We'll call this one 3, 4. And then we'll put one over here, call this one 5, 6. Put one over here and call this one 7, 8. And then we'll put one over here and call this one 2, 3. Put one over here and call it 6, 7. And then let's just put one over here and call it combine. Okay, so 1 and 2 will get wired into here. 3 and 4 into there. 5 and 6 into here. 7 and 8 into there. And then 6 and 7 into these. 2, and well, basically, you see what I'm doing. Okay, and now we have to just set these values. So let's see, what are we going to do? This one is more than that. So I think this one should switch that. Yep. And then this one should get switched by, I think, over here. Okay. And I'm going to change these later, but this is just for now what these values are going to be. So they're just running off of these modules. And you can see that these work. So basically, it switches from this one. This selects module switches from 1 to 2. And then it moves over to this. So suddenly we're hearing this one. And then it goes 3 to 4. Okay? And then, I think this one will be, I think, over here. Yep. And then the 5. So yeah, they're just going corresponding down each one. Or is that right? Just a second. This one goes from, which one does this one go from? It's more equal to 75. It's more than 1. It's greater or equal to 1. Which one did I have that running from now? Now I'm a little confused. I could probably just run it from here. Let me see. No. Wait, no, this one's supposed to be, I messed up. This one should be running off of here. This one should be running off of, I think, here. Yeah, this one should be running off of there. Okay, yeah, I just messed that up. Okay, yeah, you can see the dots are all moving correctly. And so now we can grab an oscilloscope. Let's put it on maybe slow or fast. Run this output into here and just make sure that our values are going up. Okay, so that's working correctly now. So that's that part. And now, in order to get all the directions going, that's going to be a whole, not the directions going, the, what do you call it? The length knob. So that was what switched it between whether it was playing 1, whether it was playing 2, whether it was playing 4 or 8. So let me just put this over here. Bring these over here. All right. Let me zoom out a little bit. Okay, so to set all that up, what I'm going to do is basically have a series of merge modules that are going to be controlling each one of these sequencers instead of these selects, and they're going to merge between the different options of lengths, so they'll all be controlled by the length knob. So let's go to mix and grab a merge module, set it to nearest, put it on 4 inputs, and make 8 of them. Actually, before we do that, let me just wire in the value. So let's call this length. Run this into here. Okay, and then let's just duplicate these. And then let's replace these cables with the outputs from these. So 1 to 1, 2 to 2, 3 to 3, oops, 4 to 4, excuse me, 5 to 5, 6 to 6, 7 to 7, and 8 to 8. Okay, and then for the bottom input, we can just run them directly out of these select modules. So because when it's at all the way length, it's going to play all 8 of them. So we can just run these directly in. The complicated parts are going to be basically we have to set up some logic for the first few, but let's just run these in. And I've tried a few different ways to get this length knob working, and they've always been glitchy, and this one just seems to be working for me, but it's a bit of a pain in the ass to set up. But, you know, like I said, you only have to do it once, and then you can basically keep using this patch idea. So the idea over here is that we want to basically decide at depending on which length it is, where the phase is going to go. So if the length is all the way down, the only one that's playing is this one. So we can just run the scalar directly into the first input. And then for the second input, so let's see, what do I have? For the second input, so what we're going to do is we're going to go to logic, grab some OR modules, and let's make them green just to differentiate them from the ands because it's hard to see the difference. And then, so we're going to have 3 of them. And then, let me just look. I took a screenshot of how I had it set up. Okay. So we're gonna have and 1. So every other ones, and 1 and 3 into here, and then and 5 and 7 into here. We're going to run both of these into here. And so the purpose of that is that we want it to keep looping back this over and over again at each one of these points of the phase. So at every other one, it's just going to loop this back. So that's going to basically control 2B over here. Or wait, what was I going to say? 1B. So that's the next length. And then what we're going to have to do is, oh, wait a second. That doesn't control that. What am I doing? That's going to trigger a select that's going to allow the phase in. So let me see. How did I have that going? 1B. Yeah. Okay. So what we're going to do is get a select. Let's call this one 1B. This is going to go to the trigger input. Hopefully you can see all this. All right. So that's going to the trigger input. And then we're going to run our scalar into the lower input and then run that into here. So that'll be 1B. And then we're going to have to do kind of the same thing for 2B because on the second length, we only have we have the 2 sequencers playing. So let me just run this out here. Okay, so basically for the other setup, we're going to do the opposite. It's going to be every other one. So let's just grab, again, a series of OR modules. Make them green. 3 of them. So basically we're going to run in 2 and 4 and 6 and 8 and then combine them. So I'm running, that's out of the AND modules over here. And then get a select again. Let's call this one 2B. And these ones are going to be the most kind of complicated to set up. After that, it gets a lot simpler because there's less options. And so that's going to go over here. And so now if we put the length over here, it should, oh wait, why is it playing all of them? Let me see. Oh, it's because I haven't, don't worry about the oscilloscope yet because now we have to change the routing up here. But at least for now, let's just deal with the visual part of this. So it should play one after the other like that, okay? So yeah, if we're on the lowest one, it's looping 1. If we're on the second one, it's looping 2. And now let's deal with the next row. So 1C is going to be. So now let's get another OR module. Make it green again. And this one's going to run out of AND 1 and AND 5. And again, get a select module. We'll call this one 1C. Run the lower input from the scalar, and then run this into that input. So now the first sequencer is all set up. But since right now we're working on the 4 length, we're just going to have to set up the inputs for the other 3 over here. So let me see whatever 2C. 2C is 2 and 6, so very similar. Let me just copy this. Delete those. Let's call this 2C. And run that out of 2 and 6. And yeah, there might be a simpler way of doing all this. I'm sure there is, but I don't know. I've tried all sorts of stuff, and this has just been kind of what works for me. Why is that? Oh, that's running out of the wrong thing. This one should be running out of the and. They're both, all of these are being, the ands are what's running into these. Okay, so that's going to go into here. And then 3C is going to be coming from, what was that one running from? I think it's 3 and 7. Yeah, 3C should be 3 and 7. Yeah. So let's just, maybe we can just copy these again. And so the reason, we're doing these twice is that we're basically, because the phase keeps going, so we're wanting to just repeat each, we're trying to basically repeat it. So this one's saying that like at step 3, and then again at step 7, it'll allow in that phase. So this one is going to come from 3, from and number 3. This one will come from and number 7. And yeah, I wish we could hide these wires, but we can't. Let's call this one. Oh shit, did I just run that? Oh no, it's the right one. Let's call this 3C. Run that into here. And then this last one is going to come from, let's see, I think it comes from 4 and 8. Yeah. And 4 and 8. And that'll go into the 4th input. Let's call that 4C. I know this, I think, is a little bit more of a complicated way than I had on that other video, but anyway, we still have to wire all these, or just change these up. It's not too much work, but let's first just make sure that the lengths look correct now. So if we're on the lowest one, we have 1. The second one, we have 2. The third, we have 4. And the last one, we have all 8. Okay? And now, what we have to do is basically change a couple things on these now, because they're not playing, because the orders have to change depending on where we're at. So what we're going to do first is grab a merge, give it 4 inputs, make it on nearest. This will also be controlled by the length. And so basically this is just going to decide, depending on what length we are, which input comes in. So at the first one, we're only getting the first sequencer, so we can just run it right from there. The second one, we're getting 1 and 2, so we can run that from here. But we have to change now the control input for 1 and 2. So what we're going to do is we're going to run, let me see, how did I have that? Let's see. I thought I took a picture of it, but I don't remember exactly. Oh yeah, the control input is going to 2B. It's also going, okay, so it looks like I had the same OR module that's going into 2B is controlling that. So where's 2B? So yeah, this one over here can run into 1, 2, and 3, 4. So it's basically just going to keep them constantly changing between one after another, but you're not going to hear it all the time because the other ones are also switching. Okay? And so then what do we have? So then we're going to have these ones running into the third input over here. And did I change what the input was for 2, 3? Yeah, okay, so I also have, and I also have to change the input for 2, 3. So we're going to get another OR. And we're going to run the top input from, we have to get 3 of them. Okay, so this one is going to come from when the phase is more than 25. So right here, it's 25, right? 25, 50. Okay, and then the other one is going to come from here, which is when it's less than 50. Okay, and now the other one is going to be from 75 and 100. So this one will be from when it's more than 75, or sorry, from when it's less than 75. No, yeah, sorry, when it's more than 75 and when it's less than 100. So this will come from here, and then the last one should come from here. These two should run into here. And then that should control, I know that looks a little complicated, but hopefully the math all makes sense. This should control the, what is it, the 2-3. Yeah, the 2-3. So we can just wire that in. And now let's check the oscilloscope and make sure that these are all working right for the different lengths, and then we'll work on direction. So if we're on the lowest length, what the hell is going wrong? Oh shit, that's not, okay, this needs to be powered into there, and then the combined input should be going here. This should be going here. Okay. So the combined input goes into the lowest one, and now we're going to run this into the main merge module into the oscilloscope. So the lowest input is basically the lowest value. The next one, you can see that is alternating. Let me change this to maybe fast so we can see. No, keep it on slow. All right, and then the next one up. Oh, wait, is that above? Wait, something's going wrong. So 1, 2, 2, 3. Oh, this is stuck. So something's wrong over here. Oh, wait, these aren't supposed to be ors. These are supposed to be ands. That's the problem. Whoops. Okay. So let's check it now. Okay, there we go. Yeah, I just messed that up. So you can see now we have the 4 repeating. And then if we bring it all the way up, we have 8. Okay, so now everything works. So we have lowest is there. Then the next one is alternating between these two. The next one is alternating between the 4, and this one's alternating between 8. And the values are working. All right, so that's now everything that we need for basically having the 4 sequencers with these 2 knobs, the length, the timing and the length. And yeah, I'll clean up the interface in a minute. The only parts we're going to want on the interface are going to be these sequencers and these 2 knobs. All the rest of this is going to be hidden off in space. So now for the direction, I hope I can remember all this because I didn't screenshot enough of it. Yeah, I'm just going to have to try to remember all this. Okay. So this is what we're going to do. Let's get a merge and a split. Put them both on nearest and set them both to 4. Get a value. Call it dir for direction. And And then I can't remember how to move a whole cluster of cables right now. So let's just grab an attenuator, delete that, run it into here, delete the attenuator, and run this output into here. And so now our first direction is forward, so that can just go direct. The second direction is reverse, so we can just simply grab a reverse. Where the hell is the reverse? Here it is. Grab a reverse, run that into the second one. So then for the third one, what we're going to do is we're going to get a scalar, make it 1/2. Is that what I had? Let me just look real quick. How did I have it? Oh no, it wasn't 1/. I used to do it 1/2. Now we have to have it for different values because of the length knob. So basically, you know, what we're doing is that we're basically doubling the phase, and we're saying that once it hits 50% of that, it'll trigger it into reverse. Okay, so what we're gonna do is get a select, and the normal way will just be running forward. The reverse way will be triggered by these scalars. So let's get it. Excuse me. Let's get another split and merge series. So 4 of them. I mean 2 of them, but with 4 inputs each and both on nearest. And these ones are going to have different values than the ones I did on the other direction video, because again, this is 8 sequencers instead of 4, so the values are different. So the top one is going to be 4/1. The next one is going to be 2/1. The next one will be 1/2 that down here, and that one skipped because it's just 1/1. We can wire these in. And then the phase from this comes from our main phase over here. Right? Let me just make sure everything looks right over there. Right, yeah. And then the control inputs for these are going to come from the length knob. Which, let me make sure that that's the length. Yeah, that's the length over there. So we can run these into there. And then what we're going to do is we're going to say that if I think we have to put a reset, but I don't remember. I'm just going to do it anyway. So let's get a phase, put it over here. And we're going to say that if this value is greater or equal to 0.5, so let's go to a logic. Get this. We're going to say if this value is greater or equal to, get a math constant, make it 0.5. Run that into here. Then that's going to trigger a select, which is going to run a reversed version. So let's go to phase, reverse, and run that into here. And let's just check these first few and make sure that they're working. So where's the direction knob? It's over here. Okay, so our first direction is normal. Second direction should be reverse, so that's reversed. And now the third one should be pendulum. So let's make sure that works. That works. And let's test out pendulum for the different lengths. So if we put it over here at 4, make sure that works. That works fine. Put it at 2. All right, 1. Okay, so and we can test the other ones for reverse. Yeah, everything's working fine. So then the last one is going to be random. I'm trying to remember how I did this. I didn't snapshot it because I've done this a few different ways, but I think that what we're going to do is let's run it through triggers. Okay, that's what I did. All right, so I just had a noise going into a sample and hold. So let's just go to random. Let's run a noise into a sample and hold. And then let's get a triggers. And I think we need to turn off the phase input, run it from here. Yeah, run it from here. And then run the triggers into the gate input of the sample and hold, and then just run that into here. I think that works. You might have to change the value. I think I had this one on 32. And then, yeah, we can kind of just put all this stuff into here to clean up this whole setup. And so let's just make sure that works now. Oh, it's because the timing's really fast. Wait a minute. I don't know why that's looking a little weird. Is it not getting the whole length? Oh, there, it's getting the whole length, but it's doing these big long values. You might want to play with the triggers. Anyway, you can play with the triggers and see if the random looks better, but that's the general idea. Yeah, I don't want to get into too much troubleshooting on here. Oh yeah, the length. Yeah, the values need to be different because you can see the size. Oh no, I think they need to be the same. You can play with the value of the triggers. So anyway, once all this is done, we have a big mess over here. So let's just label these things. So I'll call this one just global time. And you can put a clock divider and multiplier after the global time. I usually do that because I like to have that for the whole setup. All right. And so here, put this up here. Right now I'm just cleaning it up. Basically all the work is done. Just throw that in there just to keep the space clean. All right, so now we can get some labels. We can just call this seek1 time. I'll call this one seek2 direction, or seek1 direction. And then, let's make this one over here we just call this seek1, I don't know, logic. We can kind of move all these together just to clean this all up. Let's first actually move all this stuff out over here. And I guess I'm doing this, if you are going to follow along this video, I'm going to use this sequencer for the videos on the stutter sequencer and the slicing for this whole glitch sequencer setup. But those videos will kind of stand on their own because you don't need these sequencer setups. This is just, how I like to do it. And I know it's a little bit of a geeky process to get this going the first time. But, if you've done this now, you can use these for any patches that have sequencers in them. Let's just move this whole thing. like that. So then basically this part over here, this row would be the only part you would see on the whole interface. You can make these match the same color. And then this part over here, we can just kind of put like over here, maybe put a label on top of it and say length knob, because that's what all that's for. I don't know why I do underscores, just because I'm a nerd. All right. And then we can just kind of put these over here just to save, just to kind of keep things looking. Shit, I just unplugged something. Just to keep things looking sort of neat. All right, so now if you want to have a bunch of lanes that are copied that are running off this same setup, well, first let me clean this. Here. All you have to do now, if you want to have multiple lanes, is just grab this section and you can just duplicate it. And now you'll have multiple lanes you can see that are running off the same setup. So you can set up multiple lanes for a patch off the same setup. And then if you want to have lanes that are running independently of each other, then what you would do is you would just copy the whole thing. So you would just copy all of this, and that would be like sequencer setup 2. If you have too many of them, your CPU is going to start to get high. But like, so the way I have it on my kind of glitch sequencer thing that I kind of started this whole tutorial series off with was that everything that was related to the gate, so that was basically the triggers, the retriggers, the probability, and the slice. Or no, it wasn't even the slice. It was the triggers, the retriggers, and the probability were all controlled by one. Then I had everything that was related to pitch controlled by another set, and everything that was related to slice controlled by another one, and then sample select by another one. So all these can run independently of each other, so that you basically get like, you can get a lot of randomization and different kind of movement between your sequencer rows. And yeah, so hopefully that's helpful to people. I know this is a tutorial that didn't involve a single sound being played, but yeah, thanks for watching and see you next time. Okay, bye.